See refrigeration. Myself, I am Raj Kumar, Assistant Professor, Department of Mechanical Engineering, Rogni College of Engineering and Technology. Refrigeration. Refrigeration is defined as the science of providing and maintaining the temperature below that of the surrounding atmosphere. That is, the aim being to cool some product or space to the required temperature. For this to be achieved, heat has to be removed from the source of a lower temperature and rejected to the atmosphere at a higher temperature. That is unit of refrigeration. The unit of refrigeration is called ton of refrigeration. We can say TR, which is defined as the quantity of heat to be removed to produce 1 ton of ice at 0 degree centigrade within 24 hours when the initial condition of water is also at 0 degree centigrade. In the SI unit, 1 ton of refrigeration is equivalent to 210 kilojoule per minute or 3.5 kilowatt. The air conditioner are also specified by the same unit, ton of refrigeration. Then performance of refrigerator. When the refrigerator is removing heat, that is heat symbol is Q. Amount of heat that is it is also called cooling load, consuming W, that is amount of work. Then the performance of the refrigerator is determined by the ratio of Q divided by W, which is called the coefficient of performance. That is the ratio between the work done to heat supply to work done. That is output by input. When Q and W are in the same unit. An application of refrigeration in water cooler to supply the cold water for drinking, to manufacture ice for preservation of food, vegetables, milk, etc. Different types of industry applications also use the refrigeration for air conditioning in a house, offices, theater, hospital, computer center, etc. The refrigerants. A refrigerant is the working fluid in a refrigerator. It is capable of absorbing heat at a lower temperature and rejecting the heat at a higher temperature in the form of a sensible heat or latent heat or both. Then desirable property of refrigerant. The common refrigerant we using the refrigerant should be good properties. Then the first property is low boiling point, low freezing point, high latent heat of evaporation, low specific heat and low viscosity. It should be easy to liquefy and odorless and no hazardous effect on leakage, chemical stability, no flammable and low cost. And different types of refrigerants we are using, Freon 12 and or 134A and Freon 22 ammonia, these are sulfur dioxide. These are the different types of refrigerant. The method of refrigerants. So different method of refrigeration is there. The one is first one vapor compressor refrigeration system, second one vapor absorption refrigeration system, in which the vapor compressor refrigeration is means it consists of the different parts. That is, a vapor compressor refrigeration system is widely used in the refrigeration applications like refrigerator, water cooler, air conditioner and cold storage. The schematic diagram of this system is you can see this image. It consists of the compressor, condenser, evaporator and expansion valve. That is a vapor compression systems. Totally these are the components is there. In which the reciprocating vapor compressor compress the incoming low pressure vapor refrigerant into high pressure vapor refrigerant. The function of the expansion valve is, that is capillary tube, is to reduce the pressure of high pressure liquid refrigerant into low pressure liquid refrigerant. Condenser, the function is condenser and evaporator are the devices. Okay, the condenser main function is to vapor liquid is converted into liquid refrigerant. Okay, the working principle of this vapor compression system means, first of all, the low pressure refrigerant vapor coming out of the evaporator flows into the compressor. The compressor is driven by a prime mover. In the compressor, the refrigerant vapor is compressed. Okay, then the high pressure refrigerant vapor from the compressor is then passed through the condenser. Then the refrigerant gives out the heat is had taken into evaporator. Then the heat equivalent of work done on it on the compressor. Actually the heat is carried out by a condenser medium which may be air or water. In the high pressure liquid refrigerant then enter the expansion valve. The expansion valve, the main function of the expansion valve is high pressure refrigerant into converted into low pressure refrigerant. The valves allow the to high pressure liquid refrigerant to control rate in the evaporator. While passing through these walls, the liquefied partially evaporated. Most of the refrigerant is vaporized only in the evaporator at low pressure. In the evaporator, the liquid refrigerant absorbs its latent heat of vaporization from the material which is to be cooled. Thus, the refrigerant effect is obtained. Then the low pressure refrigerant enter the compressor and the cycle is repeated. This is the working principle of the vapor compression system. This is the domestic refrigeration system. We know this all are we know because our house having the domestic refrigeration system. The same working principle in the vapor compressor refrigeration system. The component you can see this evaporator and capillary tube and compressor condenser. These are the parts in the domestic refrigeration. Same as the working principle. The vapor compressor is in the working is in the domestic refrigeration system. Then next we are going to see the vapor absorber system. Vapor absorber system consists of system condenser and expansion valve and evaporator. The performance the same as in the vapor compression method. But in addition to this system has an observer, the heat exchanger, and analysis and rectifier. The dry ammonia vapor at low pressure passes into the observer from the evaporator. In this observer, the dry ammonia vapor is dissolved in the cooled water and strong solution of ammonia is formed. The heat evolved during the observation of ammonia is removed by circulating cold water through the coil kept in observer. The highly concentrated the ammonia is pumped by the pump to generate through the heat exchanger. In the heat exchanger, the strong ammonia solution is heated by the hot weak solutions returning from the generation to the observer. The generator, the warm solution is further heated by the steam coil, gas or electricity, and the ammonia vapor is driven out of solution. The boiling point of ammonia is less than the water. Hence, the vapor leaving the generator are mainly of ammonia. The weak ammonia solution is left in the generator is called weak aqua. The weak solution is returned to the observer. Through the heat exchanger, ammonia vapor leaving the generator may contain some water vapor. If this water vapor is allowed to the condenser and expansion valve, it may be freeze, resulting in choked flow. Analysis and rectifier are incorporated in the system before condenser. The ammonia vapor from the generator pass through a series of dry in the analysis and ammonia is separate from water vapor. The separated water vapor return to generator. Then the ammonia vapor pass through the rectifier. The rectifier resembles a condenser and water vapor still present in ammonia vapor condenses and the condensate is returned to analyze. The virtually pure ammonia vapor then passes through the condenser. The latent heat of ammonia vapor is ejected to the cooling water circulating throughout the condenser and ammonia vapor is condensate to liquid ammonia. The high pressure liquid ammonia is throttled by an expansion valve or throttle valve. This reduces the high temperature of liquid ammonia to a low value and liquid ammonia partially evaporated. Then this is led to the evaporator. In the evaporator, the liquefied fully vaporized. The latent heat of evaporation obtained from the brain or other body which is being cooled. The low pressure ammonia vapor leaving the evaporator again enter the observer and the cycle is completed. This cycle is repeated again and again to provide the refrigeration effect. These are the difference between the vapor compression and vapor absorption. Vapor compression means small in size. Vapor absorption means very large in size of same capacity. Here the refrigerant freon 1 it used. In the vapor absorption system ammonia is used. Here electric power is needed to run the compressor. Here heat input can be supplied by a heater or by exhaust steam or oven by solar energy. Here COP is higher, vapor compressor system. Here lower. Wear and tear will more. Here vapor absorption system less wear. Then vapor combustion system produce noise. Vapor absorption system silence in operation. So maintenance cost is high, and vapor absorption system maintenance cost is low. Thank you.